Hey everybody, this video tutorial is going to be a quick overview on how to upload solar production data from a third-party production modeling tool into Energy Toolbase. Our platform was designed to give users the ability to easily use whatever solar production calculator they choose. There's 3 different ways to upload solar production data into our platform. We have direct integrations with PV Watts and HelioScope, and you can also upload outside 8760 interval data from a spreadsheet. I'm going to go quickly over each way of uploading that data just so you can get kind of a feel of all of them. This is a quick look at the agenda if you'd like to skip ahead and look at a specific one. So I'm going to start by jumping into the dashboard and into an existing proposal that I've already created. Let's go right to step 4, which is where you're going to upload solar production data in whatever form that you have it. So you'll see here that there's no PV system in there right now. To add one, just click the Add PV System button, and that's going to bring up all your options when it comes to importing that data. As I mentioned, I'm going to first create an annual solar production profile using PV Watts, which is NREL's widely used open source tool. To make a quick mention, in Energy Toolbase, we do default to version 5 API of PV Watts. Our PV Watts integration is a quick and really intuitive way to generate estimates of the PV project's performance for a 1-year period. So when you click on the icon, a map is going to display the nearby TMY weather stations based on the address you put in when you created the facility or the meter. Typical meteorological data contains 1 year of hourly data that represents typical weather conditions for a specific location, and PV Watts will use the TMY data and the user-defined design specifications of the project to generate an 8760 file, which is just 365 days of hourly production data. So I'm going to choose the recommended one. And once you get to this screen, you'll see general info, which includes your PV array type, either simple or detailed. Simple means the user generically defines the equipment sizing and you just input your DC power rating. Before I do move on to the detailed, we'll quickly talk about our ETB optimizer feature, which helps you determine the right size system size if you're unsure. What it does is it runs a simulation of 10 different system sizes based on your client's unique energy profile. So I'm going to scroll down to the total electric bill savings chart, which is what most people look at. The plot points here in the x-axis show 10 different solar system sizes. Our default is to display 10 system sizes ranging from a 10% kilowatt hour offset all the way up to a 100% kilowatt hour offset size system throughout the course of a year. These different colored lines are representation of the current rate schedule and the one that your customer will be forced to. In this case, it's the DRSES. Once I choose the size that I think is going to be best for me, I will click on that plot point and it's going to automatically fill your PV array info, including the estimated cost, the physical orientation, and everything else. I'll mention the detailed system really quick. If you select the detailed PV array type option, you'll be able to select the exact PV panel, inverter, and racking type for your specific project. Once you choose your equipment, system size, and cost, you'll hit save. For time's sake, I'm just going to go back to simple. Then I'm going to hit save, and that's going to bring you an overview of all the info that you just inputted. 2 really important numbers to note are under the performance info section, and those are the annual kWh generation and also the kWh per kW yield value right here. So that was the first way to upload solar production data into your project, and that was through using our PV Watts integration. It's really quick, simple, and intuitive, and takes just a couple minutes. So now I'm going to go and create a new proposal and then upload solar production data using the HelioScope method. I'm just going to go back to the same lead I was working on and hit Add Proposal, and we'll just name this one HelioScope Proposal and hit Save. For those of you that aren't familiar, HelioScope is an industry-leading web-based PV design software tool, and it specializes in generating solar system layouts, designs, and just making valued engineering decisions. So when you utilize our integration, users can quickly create solar PV design in HelioScope and then upload it into Energy Toolbase with just a few clicks. If you go into company settings and click third-party services, you can link your HelioScope account to Energy Toolbase. And then we'll go into step 4 when you click Add PV System and then hit the HelioScope icon. Every active project and design within your HelioScope account will populate. So select the project and specific design that you want, and Energy Toolbase will auto-import the 8760 file, roof layout design image, as well as the panels and inverters that you specified in HelioScope. Energy Toolbase will also populate that design, the field segment information, and condition set, and all you have to do is hit save. We do have a longer form video webinar that shows the process of designing a system in HelioScope and importing it into our platform on our YouTube and Vimeo pages if you want to get a little bit more in depth with this way to upload solar production data. The last way to upload solar production data is through spreadsheet interval data or 8760 data. 8760 data is 1 year of 1 hour interval data, hence the 8,760 data points. I just quickly created another proposal under the same lead. So I'm going to go ahead and add another PV system. All of the major solar production calculators output their production data into an 8760 file, which is what I'm going to be demoing, including PV-Sys, PV-Sim, PV-Complete, DOE-SAM, and Aurora. The vast majority of the time, users will want to use the default 8760 local standard time option, which will always start on 1/1 and goes through 12/31. For the demo here, I'm going to go ahead and use a PV-Sim file, so let me open that. PV-Sim was a software tool developed by SunPower to produce estimates of PV system production power. Looking at this PV-Sim Excel file, there's two things that you're really going to need to pull from this right away, which is the DC power rating or the system size, which is generally up at the top of the system sizing section. I've highlighted it here in yellow. I'm going to take this size and I'm going to copy it, and I'm going to put it into our DC power rating interval data details. The DC power rating and the units of measurement are the two major things that you're going to need to input before you move on. We're also going to need to find the units of measurement. So let's scroll all the way down to that 8760 data here, and you can see that it's in kW. So let's go back and put that in. So once we've got the DC power rating and the units of measurement filled in, we can go grab the actual 8760 data. So we'll bring this file back up, and all the way at the bottom here, you'll see the average daytime AC power at 100% availability, and that's the only 8760 data that's available. We're going to input this data into Energy Toolbase as it lives in this spreadsheet, the way we were given it, assuming that it's 100% availability. Users can bring it in however they want, but for time's sake, we will stick to the way it lives in the spreadsheet. So let's copy this entire column. I'll select it and do a Control-Shift down arrow and Control-C to copy. And then over in the Energy Toolbase window, we will paste it by hitting Control-V, and always make sure that you are in the first cell selected to start the paste. So again, we'll hit Control-V and then we'll select Import. After that's complete, we'll hit Save and we'll see the same card summary view as before, showing the PV array info that was populated in from that data. After importing the data, users might want to do a quick sanity check and look at their total annual kilowatt hour production value right here. Energy Toolbase will precisely sum their total based on the data that was copied in from Excel. I do want to mention that after you've imported 8760 data in, you can auto-scale the system size up or down in our platform, and that's quickly going to auto-scale the entire 8760 data file automatically. So let's click back into this system right here and assume that the solar designer decides that only 100 kilowatts of solar capacity can fit on the roof. So we'll go ahead and change this to 100 kilowatts into the DC power rating, and then we'll hit Save. And then Energy Toolbase will regenerate that annual kWh production data automatically. You won't have to do any work. That feature is really useful when you want to rescale a project because the system size you brought in wasn't accurate or needs to be adjusted. Before ending this video, I want to quickly make mention of the multi and single column Excel import options. If a user was to select either one of these two options, notice that the starting date will align with the starting date of the energy use profile the user has referenced in step 2 of building the proposal. So if you choose either one of these options, you need to be really mindful of making sure that you have your 365-day production data perfectly aligned to the start and end date. Oftentimes, users will use one of these options when importing in actual observed solar PV production data, which is captured via an inverter or a data logger, and then they'll use Energy Toolbase to solve for the actual dollar savings achieved on a project based on both historical usage data and historical solar production data. So I just showed you all 3 ways to import solar production data into Energy Toolbase. If you're looking for more content, we have tons of educational content in our Help Center and on our YouTube and Vimeo pages.